Hey everyone, just want to take a quick look into TP 7.3's new math expression language, or MEL. You'll notice that it is very similar to some other programming languages like VEX, where we'll have a bunch of function declarations we can make, as well as parameters that go with those, declare variables, and do a bunch of complex scripting inside of that. The really great thing about this is that it opens a whole new door to multi-threading in TP, as well as access to data across the entire system, as well as doing things like creating virtual particle groups where a particle can now become part of two groups or three groups at once, and doing other things like affecting the particle shape vertex color, or even displacing or moving the particle vertices of the particle shape itself. Your own control of it, which is pretty fantastic. And that's just the beginning. You can do tons of other stuff, iterate through objects in a multi-threaded fashion, iterate through VDB data, multi-threaded. It's pretty great. Just remember that if your first input coming into the system is now this one you see has an input and the name of that variable, and this one is a port group. So groups are going to be multi-threaded, but if you were to use a particle or a scalar or a vector, then it will only be single-threaded. Okay. So this is a huge example, of course, and you can see all the different calculations somebody put in here for doing the Chladni thing. If you want to learn a bunch about these MEL things, the best thing to do is to jump into the sample files provided by CBIS, as well as watch the tutorial videos on cbis.com, as well as dive into these and kind of pick it apart and understand how these things are set up. I'm going to show you a real quick example. Not this one. This one is a little more complex as well, and this is getting memory values and dealing with averages and mins and max of those. So, but the sample files are a great place to start. In our case, we're going to use this. Oh, and I want to say, if you're not a scripter, there is still some big benefits for the TP community here, in that the operators that other users can create can be shared as black boxes, and so you can do things like access our average size, to very quickly calculate the average size or the min, the max size of all the particles, and use that in your systems, as well as, boy, anything that you can create with MEL and share as a black box. The whole community should have access to that. Doing an object face tracker, dealing with value ranges, all this stuff. These are just black boxes I've made in the meantime. So, okay, anyway, let's go ahead and create our TP and look at a very simple example. Let's create a particle born, or position born, excuse me. Let's go ahead and create 1,000 all particles, and let's set the direction way like that, and distance 100 and variation 100, and that's going to put them all in a kind of a big ball here. Okay. And let's go ahead and display these guys as bounding box. And we can see that their sizes are all the same, and we're going to go ahead and deal with the average size, just to show you an easy way to set up a system with MEL. So here we're going to, oops, maybe not 100 is not a good idea. Let's try 10, and there we go. Okay, and so what we're going to do is we want to, for many times in systems, we need to know, hey, of all the particles, what's the highest number, the lowest number, or the average? And this is an easy way to create that. To do this, we are going to use a group as our input, because we're going to analyze all the data about a particle group and deal with that data. And then in this case, we'll go ahead and just store this as a scalar. We're going to call this the average size. Okay, but here in the expression MEL, or the MEL operator, you can see that by default it's going to start with some preset values. This is defined in your thinking INI. There's a startup file that defines these. It's for now, let's just get rid of that. And we're going to use a function here, and you can see autocomplete is turned on right now. It's going to give us, based on our text, what the available current functions or parameters are. We're going to do an input description because we want to declare a new input. And let's call this, we're going to use a single quote for the name of this. We'll call it just group. And oops, we need to declare the port type. And the port type is going to be port group. And we need to close that statement with a semicolon. So let's go ahead and compile, and boom, now you see our expression mel has a group of group type coming in. And if we expand the parameter, we can actually go ahead and just pick that value right there. So we can actually set up rollouts and declare all the parameters, the high, lows, etc. for that rollout, so we don't need that all anymore. Okay. And what we're going to do is, our goal is to output the average size. Okay, and so we are going to create actually we make an output description, and we're going to call this average size, and the port type is going to be a scalar, and the port, I think the port out is going to, so the port out section here tells the output how to treat the output, basically. In this case, we want to output the average. We could output the max, the min, the Cmax, Cmin, and let's go ahead and do that. Now, to find out about this kind of stuff, and very, very important for learning mel, is to click not on a, don't highlight a character, just insert your cursor into a word and click on the shelp function. And this is going to pull up context sensitive help for whatever function it is you're dealing with. So you can see we've got all these output description examples, and in this case we also have things like, you can see that declare the output description, give it a name, the type, and in this case they're using the port out minimum. So ours will be the average. Okay, so let's try this. Let's try average size out. It's interesting, it should pick that up, but AVG size, well, we'll just do this, out equals the get. Now we're going to get the particle data, the P data, for the PID, which is a reserved keyword when using the group input. And what we're going to do is, the data we're going to get is about that particle. You can see these different data types. There's quite a few available. We're going to get the data size. Okay, now we'll go ahead and just evaluate this. You can see now we've got an output. And let's go ahead and hook this up and see what we get. Okay, now boom. Okay, so right now it's telling us our average size output is for 4.86. You get a couple other lines of debug telling us that the expression mel is starting a p group parallel operation, and it finished it and it returned that result for us. We could also come in here, you know, it would be quite easy to set up more output descriptions. Oops, if I can type, called, you know, min size, or it's a point scalar, and we could do a port out min, but I'm sure you probably already get the idea. We're able to create our own UIs and deal with data in a very nice manner. And this is really just scratching the surface. You know, like I said, you can access tons of different types of data throughout the entire TP system, all from one mel expression. And essentially you could build an entire system just with mel. There are some limitations. You can tell when you right click and you click on the mel category. These are all of the operators that are currently working directly with mel. And so you can actually use these to feed data in to the MEL system. So in this case, we're going to go ahead and say average size out. Oh, not average size out. Let's do min size out is going to be, well, instead of getting the P data every time, we could do this. So you see what I could do. One way is I could output this, and because we are going to assign, we're accessing this output, and we're going to use this data as part of the output, and this part is going to calculate the minimum for us. What we're going to do instead is we're going to declare a variable called mySize. Where it's let's go ahead and just use this. Okay, so we're declaring a variable, and then we're going to, for each of the outputs, we can just say, hey, access the mySize variable that we made, right? And so it's going to, because the output controls, it has a parameter here for controlling how the output data is handled. You know, this one's going to output the min, the average, and the max. So these assignments, they're just accessing that mySize variable, and they're figuring out how to output, or what part of it to output. Okay, so let's compile this, and let's go min and max. And one of the other nice things about MEL is that dealing with memory values is procedural. You can connect memory, has a this memory output type here, and you can input that into the MEL system to access values, or you can actually output and connect to it too, I think. And let's go ahead and do this and take a look at our min-max. Oops. Well, obviously something broke there. The max is not that. Min size out. Average size out. No, there's no max size out yet, huh? Max size out, mySize. Okay, and remember, you got to compile. Close that up, and there you can see we've got our average, our min, and our max. And then, you know, we could use those with the memory, use those to then blend our in, min, and max to do some other calculations, but that is down the line. Most important thing is, you know, study the examples that CBIS has provided, go through the help file, jump on the Discord channel or the Facebook channel, and yeah, make something cool.